Hello everyone, welcome to this vlog. My name is Satya. So today I'll be discussing as part of this vlog what happens when your Wi-Fi interface or any local area network interface starts up, right? Or connects to the residential router, right? So we will check that as part of this vlog. So this is the setup as you see on the screen. The setup looks like, so I'll be restarting, or I've already restarted the Wi-Fi interface connected to this link here, right? So which is connected to the residential router, and I have captured the packets. What happens when that process of restart is done, right? Between Wi-Fi client and the Wi-Fi access point on the residential router. When I say restart, I disconnect and connect to the access point, Wi-Fi access point, which is residing on this node, that is residential router. So let's get into the capture itself, right? I will add the capture window. So this is the capture that I'm gonna add. Okay. Yeah. Okay. So as part of the second window that I have added as part of the capture, so you see there is a DHCP request sent by the source address 0.0.0.0. That means to say that there is no IP address yet because we disconnected from the Wi-Fi access point, the Wi-Fi client residing on test PC 1 disconnected from the Wi-Fi access point, so there is no IP address. So that's why it's sending with source address 0.0.0.0 to broadcast address, which is 255.255.255.255. So it will send the DHCP request to broadcast. It will send to all the nodes in the network, in the local area network. So whoever has the DHCP server installed, he will respond with this. So the router 192.168, the third packet, which is 1137, is the packet which responds from the DHCP server 192.168.128.1 to the destination 192.168.129.14, which will be the IP address. So if you look closer at what it provides, your client IP address, right? If you see what I highlighted, that means to say that DHCP server is telling the client that your IP address is 192.168.129.14, and your MAC address, what you provided in the DHCP request, is also act by the DHCP server. Then I am just telling what are the important parameters. Then what is the DHCP server identifier? DHCP server identifier is 192.168.128.1, which is the residential router. Residential router has a lot of application. One of the application is DHCP server, which provides the IP address to the downlink host, and our host is LAN host 1 here. Then IP address release time is 2 hours. So if you don't send the DHCP request within 2 hours, then the lease is going to be cancelled. Subnet mask. In the previous videos, I have described about the subnet mask clearly, that is provided by the residential router. When I was describing as part of IP config, I also told about the subnet mask. So here we are sending a capability. The DHCP server tells that I have a capability of providing 512 IP addresses, because if it was 255.255.255.0, then it was 256 IP addresses was possible. Now it is 254. That means 2 such 256 IP addresses is possible. So 2 into 256, 512 IP addresses can be provided to the local area networks using this DHCP server. Okay, then it says who is your router. router is also 192.168.128.1. And who is your domain name server? In the router advertisement you saw that it also said the domain name server to be IPv6 router advertisement sent a domain name server to be an IPv6 DNS server. Here it is also sending the IPv4 address as part of DHCP ACK that is sent in response to DHCP request. That is, the DNS server address is 192.168.128.1 and it is a DNS proxy or a recursive DNS server. It just receives the DNS queries and it forwards to the internet DNS server. Then what is the domain name? It is home, right? That is what the domain name that is being sent. So these are the important parameters that will be provided when your end client, that is your host PC1, connects to the Wi-Fi access point. The DHCP request message will be sent. As a response from DHCP server, DHCP ACK is sent, and all the parameters what I may discuss now will be given to the end client, which is host PC1, which is described here. This one, right? Host PC1 is 192.168.129.14. I have already described that. This is the IP address. I will get it. Okay. So now next I will put ICMP v6, because IPv6 stack also is starting, right, when you disconnect. So here you see here in ICMP v6, right, whatever IP address was configured on the link, it will try to advertise to the local area host saying that does anybody has taken that IP address. So the first message will be DAD, which is called as duplicate address detection. So it is performing duplicate address detection for this particular address, right? Neighbor solicitation for FE80B314 40E for 59CC and 5BFA. So it is performing the duplicate address detection for this address, right? And it's telling inform target address is this one. Whoever has this IP address, just tell me. I will stop configuring it on my interface. Then he performs duplicate address detection for other global IPv6 address which was formed using router advertisement. Now you may ask that router solicitation was not at all sent and router advertisement was not at all received. How can we assume that this IPv6 address can be used, right? So this is in because I did not close all the windows. So I have a lot of browser windows which might be using this IPv6 global address, right? So I just disconnected from the Wi-Fi access point and captured the packets when I connected back to the Wi-Fi access point. So that's why it's assuming that IPv6 address is still used and it's checking with the local area network host, have they configured this IPv6 address when he was not online, right? So that's why these three duplicate address detection messages, as you see here, 0.0.0.0 equivalent is : which is unspecified address in IPv6 address. That means he has not configured it yet on the interface. He's asking the network that can I configure them on my interface as it's seen on my interface, right? So if anybody advertises to me saying that that address is already configured, then I will stop configuring it on my address. So after receiving no response, he configures it on the interface, the link local address, and he sends to all routers multicast address ff02::2 a router solicitation, right? When he sends the router solicitation, he gets a router advertisement from the uplink router, which is residential router, saying these are the parameters. And as you know, he advertises 2A02 AA03F prefix information is provides 880C 3801. As you see, the first 4 hexadecimal tuples are the same. If you check here, the highlighted message, that is 34th message, I am checking that 2A02, A03F, 880C, 380FUN. This is the prefix that is provided by the router advertisement here, right? So then he provides the router information, MTU, maximum transmission unit, recursive DNS server, which is the IPv6 address of the DNS server, which is same as the residential router. It will act as a DNS proxy. Then the source link layer address of your router, right? So then what he does is he sends from his link local address to FF02 ::16 the packet number 159 which I have highlighted. That means to say that he wants to send that in IPv6 there is no broadcasting of the packet. All the packets are sent to multicast address and you listen from the multicast group, right? So here you will tell that which multicast groups he does not want to listen from, right? So as you see here, multicast address changed to exclude. That means whichever multicast address that he doesn't want to listen from, he will advertise here. So this is a solicited node multicast address. When an address is configured on the network interface, as you see here on the packet 33 FF02::1 FF9C 5BFA, this is solicited node multicast address. So once you check the multicast listener report, he is telling that I don't want to listen from this particular multicast address group, right? In the same way, he sent neighbor station to FF02::1 FF369671, right? Here also is telling as part of ICMP multicast report message, I don't want to listen. That is the third multicast one. Then to B386, right? So that is also being highlighted in packet number 35, and same thing is telling I don't want to listen from that multicast group in packet number 159. Then what is this FF02::FP, which is related to an Apple Bonjour application, right? So this I am not sure in detail what exactly that application is. I will search more and I will describe, but he's also telling that he doesn't want to listen from any host advertising to this particular multicast group. So when I say exclude, he says that exclude me from listening to these multicast groups. So any host sending on these multicast groups, the host that is advertising, that is my PC host 1, will not listen to them, right? Rest of the other multicast groups he will listen to. So that's what it means, right? So I will try to remove this window, that is a capture window. That is what I wanted to discuss. So to recap, as part of this video I discussed after restarting the Wi-Fi interface, that means disconnecting from the Wi-Fi access point installed on the uplink residential router and connecting it back. First it will ask for a DHCP request, you will get a DHCP response and all the parameters will be configured including IP address. Then IPv6 stack starts from the starts on the PC LAN host 1, then all the IPv6 address will be configured. First duplicate address detection is performed, then router solicitation is sent, router advertisement is provided, which knows which will determine what will be the uplink router that we need to use. So all these things will happen, right? So this is what I wanted to discuss as part of this particular part, which is part 5, and it is as part of the series which is simple home network setup. This is part 5 of it, that is installment 5 of it. So I want to remind to the viewers, if you are not subscribed to this channel, please do subscribe. I will keep adding valuable info as part of TCP/IP networking. Okay, thank you very much. Bye.